Okay. Good afternoon, all. Are you able to see the screen?
Yes, sir.
Good afternoon,
Yes,
sir. Yes, sir.
Okay, so today we will discuss about transfer functions, and we will start a small portion of mathematical modeling of electrical systems. Okay. So first we will look into what is a transfer function. For that, let us consider one system. Okay. So I'm considering a system with an input R of t and the corresponding output C of t. So you have an input R of t, it is given to a system, and the output I am denoting as C of t. Please note that in control systems, and basically I will be denoting inputs using R of t and outputs using C of t, okay, throughout our class. Now, so this is a system having an input R of t and the corresponding output is C of t, which means that when you are giving an input R of t to the system, the output is C of t. Okay. So such a system I have considered. Now, transfer function of the system is defined as the ratio of the Laplace transform of the output to the Laplace transform of input. Okay. So please remember this definition. The transfer function of a system is defined as the ratio of Laplace transform of the output to the Laplace transform of input. So this can be mathematically written like this, correct? So H, I will be using the letter capital H to denote transfer function. H or capital G I will be using. Okay, so here I am using capital H. Okay, so capital H of S is equal to Laplace transform of C of t, which is Laplace transform of output, divided by Laplace transform of R of t, which is the Laplace transform of input. So this is the definition of Laplace transform. Okay, please remember it is the ratio of the Laplace transform of output to the Laplace transform of input. Okay. So tell me, how will you denote this Laplace transform of C of t? How will you denote Laplace transform of C of t? Any idea? Okay. Laplace transform of C of t, small c of t, I will be representing using capital letters. So in mathematics and all, you might have learned that. So h of s, which is a transfer function, is equal to c of s, which is the Laplace transform of output, divided by r of s, which is the Laplace transform of the input. So please remember this Laplace transfer function is the ratio of the Laplace transform of output to the Laplace transform of input. Is it clear? Any doubt in this?
No, sir.
Okay. So always remember this. Okay. Whenever I tell transfer function, you should remember that it is the ratio of the Laplace transform of output to the Laplace transform of input. Now, so this diagram I can, in Laplace domain, I can write like this. So R of t, okay, will become capital R of s. C of t will become C of s, and the system will be replaced with its transfer function. So transfer function actually gives the relation between the input and output actually. Okay, how the system behaves for a particular input. Now there is another definition for Laplace transform, sorry, transfer function. So transfer function is also the Laplace transform of the impulse response of the system. Okay, transfer function is also the Laplace transform of the impulse response of the system. Can anyone tell me what do you mean by impulse response of the system? What do you mean
So
by
output of an impulse signal.
output of
Output
Impulse
of
signal.
LTI system,
output of LTI system to what input?
unit step signal.
No, no, not units.
Unit impulse signal.
Yeah, unit impulse signal. Okay, so impulse response means it is the output or response of the system to a unit impulse input. Okay, similarly, step response means is the response or output of the system to a unit step input. Ramp response means it is the response or output of the system when you are applying a unit ramp signal. Okay, response means actually output. Correct. That is why it is called impulse response. Impulse response means the input is impulse. Step response means the input is step. Okay. Ramp response means the input is ramp. Is it clear?
Yes, sir.
Yes, sir.
Okay. So I can define transfer function as the Laplace transform of impulse response of the system. So there are two ways in which I have defined here transfer function. One is that it is the ratio of the Laplace transform of output to the Laplace transform of input. The second definition that I gave you is transfer function is the Laplace transform of the impulse response of the system. So do you remember which variable is used for denoting impulse response? You might have studied in your signals and systems course. Which variable is used to denote impulse response?
H of t, sir.
Correct, h of t. That is why I have given transfer function name as h of s, so that it will relate. Okay, so h of s is also the Laplace transform of h of t, where h of t is the impulse response of the system. Is this slide clear? Everything in this slide should be clear because that is very important. Any doubt in this?
No, sir.
Okay.
No doubt, sir.
Okay. So let us go into a small problem we will do. Okay. So today onwards, I will be giving some problems, three problems in the last slide. It will be mentioned and the answer also will be given. So what you have to do is you have to do it at night after your classes are over. Whenever you are free, you do it and check whether the final answer that I have written, whether you are getting the final answer or not. Clear? So one example I will be showing you now. So the question is this: the response of a linear time invariant system to an input e to the power minus 2t u of t is given as 2e to the power minus 2t u of t plus 4e to the power minus 3t u of t. Find the transfer function of the system. Also, what is the impulse response of the system? So this is the question. Okay, so what all things are given? Can you name what are those two things which is given? So please read the question and tell me what is given in this particular question. What is e to the power
Input, sir.
now? Which is
Input
that?
and output.
Now,
Input e to the power of minus 2t u of t.
okay, so how do you denote input in control systems? Which variable we are using?
R of t.
R of
So
t.
r of t is equal to e to the power minus 2t u of t. So what is the other quantity?
Output.
Output. We will be using c of t.
C
Correct.
of t.
So response is given by 2e to the power minus 2t u of t plus 4e to the power minus 3t u of t, which is the output. So I will represent it as c of t. Okay. Now what is the question? Question is to find the transfer function. So what is the definition of transfer function?
Laplace transform of
Direct.
output to the Laplace transform of input.
So can we directly divide these two?
We should find Laplace transforms.
Correct. So first we should find the Laplace transform of both the input and the output. So what is the Laplace transform of the input?
1 by s plus 2.
1 by s plus 2.
Correct. So Laplace transform of r of t, which is equal to Laplace transform of e to the power minus 2t u of t. So in the last class, I told you one formula, general formula, that is Laplace transform of e to the power minus alpha t u of t is equal to 1 by s plus alpha. So here the r of s will be 1 by s plus 2. Correct. Now what is the Laplace transform of the output?
2 by s plus 2 plus 4 by s plus 3.
Correct. 2 by Laplace transform of 2 to the power 2 into e power minus 2t plus 4 e to the power minus 3t u of t. So Laplace transform will become correct. 2 divided by s plus 2 plus 4 divided by s plus 3. So if you, I can take the LCM. Can you quickly take the LCM and tell me what is C of S? You need not denominator. You need not expand. You just keep as it is. Numerator. Can you tell me? So take LCM and quickly find out what is C of S.
Six s plus 14 divided by s plus 2 into s plus 3.
Correct, correct. So I'm taking LCM here. So 2 into s plus 3 plus 4 into s plus 2 divided by s plus 2 into s plus 3. So you will be getting 6s plus 14 divided by s plus 2 into s plus 3. Now can you tell me what will be the transfer function? Can you quickly find out? So what will be h of s? H of s is equal to, what is the formula?
C of S divided by
C
R
of
of S.
s divided by r of s.
Correct. Now you substitute that and tell me what is the answer.
Six s plus 14 divided by s plus 3.
Correct. 6s plus 14 divided by s plus 3. You will get like this: 6s plus 14 divided by s plus 2 into s plus 3. S plus 2 and s plus 2 will get cancelled. Finally, you will be getting h of s is equal to 6s plus 14 divided by s plus 3. Okay, so we got the transfer function. Now, what is the second question that is asked? That is impulse response of the system. So once you know the transfer function, how will you find the impulse response? If you know the transfer function, how will you find the impulse response?
Inverse Laplace.
Correct. Okay, so because we know that Laplace transform of impulse response is transfer function. So what will be impulse response? Impulse response will be Laplace inverse of transfer function. So that is correct. So we found the transfer function. So now impulse response will be the inverse Laplace transform of transfer function, which you told, that is correct. So I will find h of t. H of t is equal to Laplace inverse of h of s. So you have to find the Laplace inverse of 6s plus 14 divided by s plus 3. Can you find out the Laplace inverse of this? What is the Laplace inverse of this? Are you able to find? Any idea how to do this? Okay, so please remember, if the numerator degree and the denominator degree are the same, you cannot proceed. Okay, you can proceed to find the Laplace transform, Laplace inverse only if the numerator power is less than the denominator power. That is partial fraction you can do only if it is less than, correct? So first what we have to do? In this case, what you have to do first? Anyone? How will you make the degree of the numerator less than the degree of the denominator? How will you do that? Come on, it's simple only, right? You just have to divide it, correct? So I will divide it. So can you tell me what will be the quotient? What will be the quotient? 6s plus 14 divided by s plus 3. What will be the quotient? Anyone?
6.
No, 6. So it will be 6 and it will be 6s plus 13. So what is the remainder?
Minus 4.
Minus 4. Okay. Which means that I can write this as 6 minus 4 by s plus 3. Correct? 6, this whole thing can be written as 6 minus 4 by s plus 3. Then only you can apply Laplace inverse. Okay. Because if the powers are same, numerator and denominator, you cannot apply partial fraction also. You know that, right? You know that, right? Numerator and degree
Yes, sir.
denominator. Okay. So both the degrees should not be same. So the degree at the denominator should be more than the degree of the numerator. Then only you can apply. So now tell me, so this can be splitted like this. 6 into Laplace inverse of 1 minus 4 into Laplace inverse of 1 by s plus 3. Now can you tell me what is the Laplace inverse of 1?
T.
Laplace inverse of 1 is not t, right? What is the Laplace inverse
1
of?
by s.
No. The Laplace inverse. Laplace inverse means from Laplace transform, you are finding the time domain signal. What is that? What is the Laplace inverse of 1 by s plus 3? That is simple. You can tell. Right? 1 by s
E
plus
to the
3.
power of minus 3t.
E to the power minus 3t u of t. Correct. So similarly, what is the Laplace inverse of 1? So think which signal has a Laplace transform 1? Which signal's Laplace transform is 1?
Delta T.
Unit impulse.
Delta of t. So this will be 6 into del of t minus 4 e to the power minus 3t u of t. Is it clear?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
So I hope you understood this problem. So based on this transfer function concept, I have given 3 problems in the last slide. So after this class, whenever you are free, please try to do today itself before tomorrow's class. So that a final answer is also given in the slide so that you can verify whether whatever answer you have got is the same as whatever answer I got. Okay. If you are not getting, you can tell me. So I will also check my work, whether I have gone wrong anywhere, I will check. Okay. So with this, I will start what is known as mathematical modeling of electrical circuits. So in mathematical modeling, in this particular course, we will be dealing with electrical circuits. In mechanical circuits, we will be dealing with both translational and rotational motion. Okay, so these 3 things we have to cover. So first we will start with mathematical modeling of electrical circuits. So mathematical modeling means whatever physical electrical circuit you have, you will be modeling it in terms of differential equations. That is what is meant by mathematical modeling. You will be representing the system in terms of equations. Correct. That is what is meant by mathematical modeling. Whatever system, if you are able to represent it in using equations, then it becomes a mathematical model. Okay. So that is what is meant by mathematical modeling. Okay. So for that, in electrical circuits, the three basic components are resistor, inductor, and capacitor. So we will see these three elements, and we will see what is their S domain equivalent. Okay, and then we will wind up the class for today. That is what I have planned today. So I have shown here one resistor with resistance R. Okay. Now one current I of t is flowing through the resistor, and I have marked it here. So what will happen? A voltage will be developed across the resistor. Where will be the positive of the voltage? Left side or right side? If the current is flowing in this direction, where will be the positive of the voltage developed? Left side or right side? Anyone?
Right side.
No, no, no. Current entering terminal will be positive for a resistor. Okay. So voltage will be developed, and that voltage developed across the resistor, I am naming it as VR of t. Clear? Always remember, okay, the current entering terminal will be positive for a resistor, always. Okay. So now tell me, what is this VR of t?
Voltage across resistor.
So what is the mathematical equation for that? I mean, VR of t equal to what?
I of t into R.
Correct. R into I of t. Correct. Because voltage across the resistor is nothing but resistance into the current flowing through it. What law is that? What is the name of that law?
Ohm's law.
Ohm's law.
Ohm's law.
Ohm's law.
Ohm's law.
So VR of t is equal to R into I of t. Correct. Now, if I take Laplace transform on both sides of this particular equation, so this is the time domain equation, correct? It is in time domain. VR of t is equal to R into I of t. Now I am going to investigate the resistor or the behavior of the resistor in S domain. Or S domain means basically frequency domain. How does a resistor behave in the frequency domain? How does a resistor behave when you are changing the frequency of the input signal? That is what I want to know. So what I will do is I will take Laplace transform on both sides. So when you take Laplace transform on both sides, what will happen to this VR of t? What is the Laplace transform of VR of t?
VR of S.
VR of s. What is the Laplace transform of I of t?
I of S.
I of s. So
I of S.
you will get like this, correct? VR of s is equal to R into I of s. So in S domain, the impedance is voltage divided by current only. So here I am going to check what is the impedance of the resistor, which is VR of S by I of S. What is that? R itself, correct?
Yes,
Voltage
sir.
divided by current, which means that in S domain also the resistor behaves in the same way as it behaves in the time domain. Clear? Which means that if you are changing the frequency of the input signal, the resistance of the resistor does not change. It is a constant. Is it clear?
Yes,
Yes,
sir.
sir.
Okay. So if for a resistor, you are giving, suppose resistor of 100 ohm, you are giving 10 hertz signal. That resistor value will be 10 ohm only. Correct. If the value of the resistor is 10 ohm and you are giving 0 hertz or DC signal, value of the resistor will be 10 ohm only. If you are giving 220 volt 50 hertz supply, then also the resistor value will be 10 ohm itself. If you are giving 1 gigahertz, then also the resistor value will be 10 hertz. Understood? That is what is meant by the resistor value is a constant here. It doesn't change with frequency. Is that concept clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, now we will look into capacitor. Okay, obviously, according to frequency, the impedance of a capacitor varies. So see how does it vary by transforming it into the S domain. S domain basically means frequency domain. Okay, so we'll again consider one capacitor. See, a current I of t is flowing through the capacitor in this particular direction, which will cause a voltage to be developed across the capacitor, That voltage, I am naming it as Vc of t. Okay, so you have the current I of t flowing through the capacitor in this particular direction. The voltage, a time variant voltage, will be developed across the capacitor. Okay. Okay. Now tell me, I'm going to ask the question, what is the relation between charge stored Q of t in a capacitor of capacitance C and voltage Vc of t? Voltage across the capacitor is Vc and charge stored is Q. And what is the relation between Q, C and V? In your 10th standard and all, you might have learned. What is the relation between Q, C and V? What is the formula for the charge stored in a capacitor? Q equal to what? Do you remember?
C
C.
into V, sir.
V is equal
C into Q equal to C into V. Correct. So here Q of t is equal to C into Vc of t. Correct. Because here charge, I am telling it is a time varying charge. So Q of t, capacitor is a constant C, and then Vc of t, which is the voltage across the capacitor. Now, if I am differentiating this particular equation with respect to time t, what will I get? dq by dt is equal to d by dt of C Vc of t. Correct. Which can be written as dq by dt is equal to C into dVc of t by dt. Now, can you tell me what is dq by dt? What is dq by dt? What is rate of change of charge?
Voltage.
Rate of change of charge. Rate of change of charge.
Current, sir. Current.
Current. Okay. Current is the rate of change of charge actually. How much charge is crossing a particular point at a particular time instant. That is what is meant by current. Okay. So dq by dt is nothing but I of t. So I of t is equal to C into, we can write like this, C into dVc of t by dt. So this is the equation that you should remember. Current flowing through a capacitor is equal to C into dVc of t by dt. Is it clear?
Yes,
Yes,
sir.
sir.
Okay, now from this particular equation, so I got an equation for I of t. From this particular equation, can you find an equation for Vc of t? I'll give you 2-3 minutes. Can you derive an equation for Vc? I want Vc of t is equal to something. From this equation, from this last equation, can you write an equation for Vc of t?
So 1 by C into integral I of t dt.
Correct. 1 by C into integral I of t dt. Correctly. I hope you guys know how to do that, right? I have not written it here. I have just written the last, I think. What is the equation for voltage across the capacitor? 1 by C integral I of t dt. You guys know this, or should I write how I got this?
We know, sir.
You know, okay. So 1 by C integral I of t dt. So these two equations you should remember, okay? I of t is equal to C into d Vc of t by dt, and Vc of t is equal to 1 by C integral I of t dt. Okay, I hope you guys will remember these two. Now, suppose I am taking Laplace transform on both sides of this particular equation. So can you tell me what will happen? What will happen? What is the Laplace transform of I of t?
I of S.
of
I
S.
of S. What is the Laplace transform of dVc of t by dt? What is the Laplace transform of dVc of t by dt? For example, if I am giving x of t, Laplace transform is x of s. Then what is the Laplace transform of dx of t by dt?
dx of s by dt, sir.
No, 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 no. What is which is it is known as time differentiation property of Laplace transform. X of t Laplace transform is x of s. Then Laplace transform of dx of t by dt will be s into x of s. Okay, I have written here. You can. I will just show you. Okay, here. See, if Laplace transform of x of t is x of s, then Laplace transform of dx of t by dt is s into x of s. Laplace transform of d square x of t by dt square is s square into x of s. And Laplace transform of d to the power nth derivative of x of t is s raised to n into x of s. You might have studied this in your transform techniques class. Okay. You have studied that, right? Okay, so I of s will become Cs into Vc of s. Is it clear?
Yes, sir.
Okay, suppose it was d square Vc of t by dt square, then what will it be?
c s square vc of s.
See, s square will come. Okay, so from here, now you tell me what is the impedance of the capacitor? Impedance means what? Voltage divided by current. So how much is the impedance of the capacitor in S domain? From this equation, what is voltage divided by current?
1 by
c
CS.
into s.
Correct. 1 by Cs. Correct. So that is what is the impedance of the capacitor. ZC of S is equal to Vc of S by I of S, which is equal to 1 by Cs. So here you can see that the impedance of the capacitor is not a constant. It is depending on frequency. It is depending on S. S means it is j omega, which is omega is the angular frequency. So that is why the capacitance, the impedance of a capacitor is not a constant when the frequency is changing. Whereas for a resistance, the impedance of a resistance is a constant. Is it clear?
Yes, sir.
Yes, sir.
So as frequency increases, impedance of a capacitor decreases or increases?
Decreases.
Decreases because S is in the denominator. So can you tell me when the input signal or input signal is a DC signal? DC signal means what is the frequency?
0.
0. So what is the impedance of a capacitor for DC signal? S is j omega. Omega is 0. So what will happen to impedance?
Capacitance is high, sir.
What will be the impedance of the capacitor? 1 by C j omega, correct? Omega is 0. So what will happen?
Infinite. Zero.
Infinite, infinite, correct. That is why normally people will tell capacitor will block DC. So in your analog electronics class and all, they might have told you like what is that? Capacitors are used, correct, for bypass capacitor. Sorry, what is that? Coupling capacitors are used in your amplifier. So basically, that is why it is used. Okay, because it will block DC. It will pass only AC to go to the transistor. Okay. Whatever biasing input voltage that you are giving, that will not interfere with the amplification action of the transistor. That is why you are providing capacitors as coupling, because it will the DC. Okay. Now let us look into our last element, which is our inductor. So inductor, again, I am showing you one inductor L having an inductance L, and the current I of t is flowing through the inductor in this particular direction. So a voltage will be developed across the inductor. That voltage I am naming it as VL of t. So now here we are going to start with magnetic flux and current. So do you know what is the relation between magnetic flux and current? Inductance, magnetic flux and current. Phi of t is equal to what? Phi equal to what? You might have studied in your 10th standard and all. Flux, magnetic flux is equal to, anybody remember? No. Okay, magnetic flux is, okay, magnetic flux linked is equal to L into I. So here phi of t is equal to L into I of t. Okay. Now again, I am differentiating this equation with respect to time. So this will happen. D phi by dt is equal to d by dt of L I of t. So d phi by dt is equal to L into di by dt. Correct. Now what is this rate of change of flux? D phi by dt. What is rate of change of flux? What is the rate of change of flux? Don't know. Okay, rate of change of flux is simply voltage. Okay, so voltage across the inductor is nothing but the rate of change of magnetic flux linked with it. So d phi by dt is equal to VL of t, which means that VL of t is equal to L into di of t by dt. L into di of t by dt. So voltage across the inductor can be written as L into di by dt. Clear? Voltage across an inductor is given by L into rate of change of current. So from this equation, can you find an equation for I of t? What will be the equation?
One by L into integral VL of t into dt.
Okay, 1 by L integral of VL of t, correct. Okay, so these two equations you should remember. An inductor is equal to L into di by dt, and current flowing through an inductor can be given as 1 by L into VL of t dt. Okay, is it done? You understood this?
Yes, sir.
Yes, sir.
Okay. Now I'm going to take again Laplace transform on both sides of this particular equation. So what will happen? VL of t will become
VL of S.
VL of S.
VL of s, and right side will become what?
L into S I
L
of
into
S.
S.
Correct. L into s I of s. So can you tell me what is the impedance of the inductor in S domain? What is ZL of S?
LS.
LS.
Correct. Okay. So what can you infer about inductor? At DC, what does an inductor do? DC voltage
0, sir.
zero.
Inductor
Zero
is 0.
means the capacitor, the inductor will be acting as a short circuit. Okay, short circuit means no resistance. Correct. So impedance is 0 means no resistance, which means short circuit. So inductor acts as a short circuit for DC voltages actually. Similarly, capacitor acts as an open circuit for DC voltage. You might have studied this in your network theory, I think. Okay. So this is clear, right? Any doubts?
No, sir.
Okay,
No,
so let us summarize this, whatever we have done till now. There's domain equivalence of electrical elements. First one is the resistor. So in S domain, what will happen to I of t? What will
Does
happen
not
to
change, sir.
I of t? I of t will become what?
I of S.
I of s, correct. VR of s will become, sorry, VR of t will become,
VR of S.
VR of S.
and R will be
R.
R itself.
Cons.
Okay. So it will be like this, correct?
Yes, sir.
Yes, sir.
Now similarly, capacitor, what will happen to C?
C.
C will be C itself
1
only,
by
right?
CS.
1 by CS. Correct. It will be 1 by CS. Similarly, for an inductor, what will happen? L will become
LS.
LS. Correct. So this you should know. Is it clear?
Yes, sir.
Yes, sir.
Okay. Okay. Then I have given here three questions I have given, and the answers I have provided here. So please use partial fraction expansion and find out. Okay. Try to do it. If you're not getting, you can ask me. Problem. So check whether you are getting this same answer. Okay.
Okay,
Okay.
sir.
But do it today itself so that when you come in between, when you have doubt, you can ask me. Yeah. After 8 p.m., you can ask me anytime. If you are not getting,
Okay,
you can
sir.
ask me. Okay. But do it today itself so that this slide file will be, you will learn what is to be done from this particular file. Okay. Any doubts? 5 minutes is there. If you have any doubts, you can ask. Are you finding it comfortable with this course, or is it difficult? Or anyway, we have just
Fine, sir.
started, so we don't know. Hmm. Okay. Okay. If you have any doubts, you can ask.